For section 6.6, I'm going to do number 291. You're told to find the surface integral of g. G is xz plus 2x squared minus 3xy. The surface is the portion of the plane 2x minus 3y plus z equals 6 over the unit square, so x and y both are between 0 and 1. To get started with this, you have to parameterize it, and to do this one, it would be within x and y. So, and then if you got that vector form of that, it would just be x, y, and then the z would be, you can find that we're coming over here and moving to the right hand side, so the z is actually, it's 6 minus 2x plus 3y is the z component for this. And then start, I'm just going to find the magnitude of the cross product of the vector t with the x of y and t and the y. So to find that, it is just the partial derivative with respect to x of r. It's the cross product of the partial derivative with respect to r, the partial derivative of r with respect to x, and the partial derivative of r with respect to y. So if you do that, you would get 1, 0, negative 2 for the x1, and then the y would be 0, 1, 3, and then you can do the cross product of that over here. When you do that, you get k plus 2i minus 3j, which when you move it all over, you would get 2, negative 3, 1 for the cross product of the vectors t with respect to x and y. And then you got to do the integral, which would, so the surface integral of g, you just input this function in here. Oh, and I forgot something, it's actually the magnitude of that. So if you were to square these and do the square root, there would be 4 plus 9 plus 1, so you would have the square root of 14, and that's actually what that equals there. And then this would be ds. And then you can come over here and you can put the sub in the x for that. And if you did that, you would get, where's my x? You get 6x minus 2x squared plus 3xy. So this and this would cancel out if you did that. So you'd be left with just 6x. And then you have the ds equals the square root of 14, and then dx dy, so it would be times the square root of 14 dx dy, and then this would come down to 0 to 1. You could actually factor out the 6 and the square root of 14, so you get 6 square root of 14 here, 0 to 1, x, no. 0 to 1 for the y, and then you have x dx dy, and they're separate of each other, so you could actually just separate that. So it would be 0 to 1 dy times 0 to 1 x dx. This, if you integrate that, that would give you y, and then there's from 1 minus 0, so it would be just times a 1. This would be x squared over 2, so it would be times a 1/2. So it would be 6 square root of 14 times 1/2, and that would give you 3 square root of 14 for your answer for the surface integral of g.